Hey everyone, welcome to Innovation Unplugged, where we explore the real stories behind technologies shaping the future of enterprise and industry. I'm Drew Brisbitsis, your host, and today I'm joined by my very good friend, Jags Kandasamy, who's the co-founder and CEO of Latent AI. Jags, thank you again for offering your time to be with us today.
Thanks for having me, Jim.
Yeah, thank you. What I love about Latent AI is it's tackling one of the most important challenges in AI today. How do you actually take models out of the cloud and make them work in the real world? An experience that we've had, but the domain expert clearly today is Jags. And so with that, let's get this conversation going about operationalizing AI and not just building it. Jags, again, welcome to our show, and let's get unplugged, my friend. So this might be a great time to have you maybe just introduce yourself, Jags, and your background, and then sort of the early origins of Latent AI, and we'll go from there.
Definitely. Thanks, Jim. Thanks for having me again. It's been a great pleasure knowing you over the years, and thank you for all the assistance through Chasm Labs and phenomenal.
Thank you.
So, origin story. I was running a startup before this called AutoSense, where we had automated human hearing. So think about, right, like if you're listening to something 24/7 and you're streaming it back to the cloud,
Yeah.
you are in the telco space, you know how much the telcos love that kind of a bandwidth, and they try to shut you down, right?
Right. Yeah.
And you can't keep paying for that as a customer or as a vendor. So that forced us to get to the edge quickly.
Yeah.
So we had to optimize a model. We actually hand-tuned a model and put it on an edge device, and it ran there. Company got acquired, Analog Devices bought us, and one of the challenges was we had to recompile everything, rewrite every line of code for us to run that model on the Analog Devices DSP,
Yeah.
the Blackman DSP. So that challenge stayed with me when I was looking to start the next company at Latent. When we started, I was at SRI, Stanford Research Institute, as an entrepreneur in residence. And when my co-founder, Sek, had worked on some DARPA technology around compressing neural networks, compressing AI models. So my challenge of compiling models for different hardware, so we combined those two expertise together,
Yeah.
and created the pipeline that became what is today Latent AI.
Now, AI generally, my friend, over the last 3 years, for good reasons, has created a lot of, hype in the market. And it's, to me, AI is going to be a mainstay in our lives personally, but certainly in the enterprise context, it's going to be a mainstay there too. You may have seen the same thing I'm seeing is when I talk with enterprise CIOs and others, the AI is definitely on the agenda. Some of them struggle with how to actually engage. Like, what big problems do I solve first?
Yes.
The industry at large has been rumored to be experiencing a bubble. I think a bubble is likely to happen, and it's probably going to create a good correction. But I'd love to get your perspective over the next 2 to 3 years in the enterprise engagements that Latent has been involved in, and there's been several. Where are you seeing enterprises really invest in AI?
So we can look at it from manufacturing,
Yeah.
retail, and infrastructure perspective, right? Most of the AI that we've been involved in is around the physical world.
Yeah.
What we call physical AI today, right? Like now is the nom de vogue right now, because Jensen called it physical AI. We were doing physical AI 6 years ago.
Yes, you were.
What we were calling edge AI, right? I had automated human hearing first, so the listening side was taken care of. Then the next one, we focused on vision and RF and other type of sensor modalities today.
Yeah.
Right. So where most of the investments are going in today is people have done computer vision algorithms. So we worked with a large CPG company doing quality control on their finished products.
Yeah.
That's number one. Number two, from a retail perspective, we worked with a large mall operator. They wanted to see what the footfall in particular lanes in their mall were, like which store people are coming in, how many people are coming in, what is the demographics of them, right? Like male, female, children, right? And this was a high-end mall, and they wanted to make sure that everybody is being provided proper customer service. So that's another one.
Yeah.
Then from an infrastructure perspective, people are using computer vision to look at infrastructure pieces and figure out if there is degradation, predictive maintenance type issues that they want to address.
Yeah.
Okay. lot has gone into pilots so far. So
Yeah.
I'll start with this manufacturing company. Right? They went into a pilot. They were going to deploy AI models, and for every plant, every production line, they needed a large server with multiple GPUs in them to run. They were already coming to the edge. But the reason they came to us was that if they needed to scale that particular pilot into production, they needed to buy that server for every line.
Yeah.
100 lines in one plant and 70 plants worldwide.
Wow.
You
Footprint.
can see the cost
Yeah.
adding up, right? So we were able to optimize their model and literally reduce their hardware footprint by 92%.
One of the misconceptions I think many people might have of Latent, my friend, is that Latent itself is its own model, but you're very friendly with all models. I don't
We
necessarily think
are.
you care really what models customers are using, correct?
Yes, that is correct. So we actually have an automation framework in our lab here, right? Like in Princeton, we take different like focused on vision models, right? Like computer vision models. We've optimized them and we run them on different hardware targets, starting from a Raspberry Pi all the way to a H200 GPU,
Right.
right? And everything in between, right? Qualcomm's, Intel's, AMD's. We run them on them. It's not theoretical measurement. We actually run and measure how fast does the model run, how much memory does it take, how much power does it draw, what is the relative action. About 20 different parameters that we collect from these models,
Yeah.
from these runtimes. So
Yeah.
we know when we recommend to a customer, hey, use this model with this hardware, you're going to get this result.
Yeah.
In the
Deterministic. Yeah.
non-deterministic world of AI, we provide determinism in the process.
Right. The manufacturing use case you shared with me, my friend, is one that is near and dear to us. As you know, we've been working quite closely with Microsoft and AT&T on the telco opportunity for edge AI because in many cases their network is touching or nearby the data that enterprises need to get to. And for AI to be successful longer term, it's going to have to be fed. These models will have to be fed continuous streams of data for the agentic actions to make sense of that data, predictions, and then take actions on them as well. So there's a huge role for the carriers in that world. But carriers aside and technology aside for a moment, I think the data that sits on the edge is going to be as valuable as the data that sits inside an enterprise hyperscale tenant or private cloud or GPU cluster or what have you. With that in mind, how important is the edge now becoming to enterprises as they're trying to figure out their strategy for AI and where they're starting to make those bets?
We have enough gray hair to know, we've seen the pendulum swing a couple of times already,
Yeah,
right? We
right.
went from, desktops to client server model back to thin clients and then back to the cloud. And then the pendulum is swinging back again to the edge.
Yeah,
Right? We worked on these technologies over the years, over the last few decades, right?
yeah,
So edge is becoming critical for a few reasons. One, the amount of data that we're going to be collecting.
yeah,
Physical world, physical AI, the analog to digital conversion, right? Like that's my famous go-to line. Analog to digital conversion is going to happen at an extraordinary level.
yeah,
And you are more familiar with the concept of induced demand.
yeah,
Telcos live this daily, right? Like I increase my bandwidth and suddenly I plan for like twice the bandwidth and I increase it 4 times. And within 6 months, that entire bandwidth is occupied,
yeah,
right? Highway lanes, all of that. That happens with compute as well. The moment you put things, people start to add more to it. So all of that is going to cause concerns. So hence, coming to the edge helps customers or enterprises to save money, and
yeah,
also they can properly define the problem set closer to where the action is happening.
yeah. One of the biggest learnings, Jags, that we've had in the Telco AI Cloud project is there aren't many like yourselves. There aren't many people doing AI in the edge. And where they are, they're band-aiding the infrastructure, as you rightly pointed out in that use case with your manufacturing client. They're band-aiding this infrastructure together to make it happen. I know you understand this better than anybody, but running AI on the edge is hard. And if you were to counsel or coach an enterprise around what it takes to do it, what are some of the key observations or the potholes that they should be aware of when they think about extending their AI intelligence out to the edge, and then taking action on that data in real time or near real time as they can.
So that is the key right there, Jim. Does the action, that's the intelligence, need to be real time?
Yeah.
If it is not real time, if you don't need it real time, don't go to the edge. Stream the data. If you have the methodology to stream the data back to a cloud and online real-time transaction processing versus batch processing.
Yeah.
We've lived this, right? Like, again, it's the same technology or same problem set with new terminologies.
100%, yeah.
Right? So if it is batch processing, ship it to the cloud, ship it to wherever you have enough compute and power, deal with it over there. Don't have to deal with it on a real-time basis. Sure. Real-time systems, you have manufacturing, you have, say, retail, you want to understand customer movement from a shrinkage reduction perspective. That's not a post thing, right? Like it's not a post analysis. So areas like this, identify your use case, that real-time processing is necessary, and do that. And while you're doing that, define that problem very clearly. Mm-hmm. We've talked about edge continuum in the past, Jim.
Yeah.
Edge continuum is not a location. Edge is not a location. Edge is a continuum.
Yeah.
Right. We've defined this as your device edge, sensor edge, device edge. A mech could be another edge in the continuum. A CDN could be another edge. Yeah. Right. How do you string the inference along this pathway?
Right.
I'll give you one example. Right. Like this is a very rudimentary example, but everybody will catch on. Doorbell cameras.
Yeah.
Doorbell cameras are just motion activated today. How about we put an AI model in there that only detects whether there is a human being present on the field of view? Mm-hmm. That's the only model that runs at that device edge level. The moment the human is identified, then you can pass the frame on to the next layer of compute. It could be a set-top box in your house. And that set-top box is doing a processing around like, is that person Jags or Jim at the door?
Right.
I don't need to do anything. Right? If I don't identify the person, then I send that frame to the third layer of compute. In this reason, could be a mech, right? At the telco edge, send it to there. And there you're processing multiple things. Is that person wearing a uniform? Delivery, Amazon, or a USPS or a UPS or a FedEx person. Are they carrying something in their hand? Mm. Is their face occluded? Right? So you can reason out these things and then you can provide that intelligence of like what next step needs to be taken at the door.
Yeah. Right? I hear you. Yes, 100%. 100%. I want to come back to something you said, which was if it's a real-time use case, you got to move the intelligence close to where the data is, right? Just simply because of physics and distance and everything else. 100%. I'm asking this question honestly because I've asked this of several different enterprises and I'm getting mixed results. If I have built a model and that model is helping me to, and this is a great use case in utilities. I build a model because I want to be able to measure vegetation growth along power lines. And as vegetation continues to grow and impede on power lines, that's, generate a ticket. That data you said stream to the, to wherever you're running it. And it could be a Mac, it could be, it could be a server nearby, what have you. But it's not real time. I guess my question for you, Jags, is the cost of streaming that data is expensive. When you think about ExpressRoute or the AWS equivalent of such, moving a lot of this physical AI data that can, be trained against a model and inferenced against that model for the model to get smarter. Although the use case isn't real time, it's still valuable data. And the enterprises that I've spoken to, they haven't taken that step for the simple economics reason of that could be terabytes of data a year I'm moving for models that aren't necessarily going to take any action in real time, but are fundamentally really important to my operations down the road. So I guess what I'm saying is there's a chicken and egg.
Yep.
because moving data from point A to point B is never going to be free entirely. There's always a cost. And when you're moving large and large and large amounts of data in the hyperscaler context, that there's a price on that.
There is. There is.
So I guess I'm not suggesting you're wrong at all. You're absolutely correct. Many enterprises struggle with this, and I'm now wondering, does it even for non-real time workloads, does it make sense to have the ability to run inferencing at least at a minimum, so you're not moving volumes of massive amounts of data, but you're also not losing the effectiveness of these bigger models that you do run and train and retrain into big clouds? Because again, cat and mouse, right? There's chicken and egg issue here at this point.
Absolutely. So this is why you're absolutely right on this, right? So the example that I gave in terms of real time versus batch processing,
Yeah.
that's one layer, right? Now I explained the edge continuum piece.
Right.
We are actually working with a customer that is in the utility space, right? Like they are serving the utilities. So in this case of vegetation over transmission lines, if I'm flying a drone, a fixed wing or a rotary wing, or even a drone that is capturing this power line, power line, power line, power line, power line, if I keep transmitting all of that data back,
Yes.
I'm burning through. But the moment I'm looking for any type of incursion on a power line, I don't know what that is.
Yeah.
That's
Something
an
looks
anomaly.
different. Yes. Yeah.
The moment I catch that anomaly, can I then send it back, or can I process that locally? Right? Like there are two different things you can do. If that drone has got enough power, enough computing power, you can process it there. But if it doesn't, you can do the filtering right there.
Yes.
Right.
That's it.
So that is the key there, right? So in the case of the manufacturing client that I was talking about, they have 14 megapixel cameras, 20 of them per line, and taking 24/7 pictures. Imagine the bandwidth on that.
Oh, yeah, City of Bellevue, my friend, who we have done a pilot with, as you know, right, for pedestrian safety, real-time model, running on the edge in AT&T's cloud. It is 16 terabytes of data a year. Petabytes. 16 petabytes of data a year, which could cost them as much as $800 to $1 million a year in transport before anything else.
Yeah.
Right? And yeah, so you're absolutely correct. Speaking of use cases, there's one where our teams have actually met in the field together, and it's in defense. There's a lot going on today in the world, and there's a lot now, I would say, high interest in the use of AI in defense scenarios. And so without breaking into jail or divulging much, there's been some really impressive work that I would suggest has battle-hardened latent AI, even more so than it has already proven itself in the enterprise. Where you can publicly, I'd love for you just to maybe touch on some of the higher level use cases, and perhaps even the similarity of those use cases in defense that have applicability to even the enterprise as well.
Yeah, so I touched upon physical AI, right? Like this new fad about physical AI. Public use case, this has been a distribution A that the Department of War has already talked about out there, is that we helped Navy deploy sonar-based mine detection models to run on an unmanned underwater vehicle, which is a submarine drone.
Yes.
Okay, so that is basically like, you're collecting sonar data.
Yeah.
In an unforgiving environment underwater.
Right. Where radio frequencies don't travel all that well, so you can't connect them.
Exactly. And even if you're using acoustic signals for communication, the bandwidth is not there.
Right.
Right. So prior to this, the Navy used to collect the data, fish the UUV out, download the data, process it,
yeah,
figure out what's going on, and then go back for another run.
Right.
Now we've got real-time tracking going on.
Awesome. So you're running a latent AI. Latent AI is running models on the vessels who are discovering, where these objects are, and in real time informing folks. So we're not having to stop collection of data and download and process and make sense of it. no one move because you don't want to hit a bind, and then put the vehicle back in.
Exactly. And then
Yeah,
you talked about the hardening part of us, right? Like, so
yeah,
latent runtime is running on there.
yeah,
And we operate under the assumption that these devices are attritable. They're going to be captured or lost.
right,
So you have to have the highest security.
right.
So we have model encryption built in, right? We encrypt the model, we watermark the model, so there is no reverse engineering, there is no manipulating of things in there.
Yeah,
So we ensure all of that happens. And then, of course, we are API first, right? The runtime is API bound, so all the applications can bind to that
yeah,
easily,
yeah,
right? So model can be changed frequently than the application, because
yeah,
application have a longer life cycle than the model. So we are able to update models. Like, for example, we went and did an exercise in the coast of Sydney, Australia,
yeah,
as part of the AUKUS exercise, right? Australia, UK, and US. In that scenario, we were in a new place, new data, new ocean floor. We had to collect the data, retrain the model, and redeploy it within days. We brought that speed to the Navy as well,
yeah.
which would have taken 6-9 months before. Collect the data, ship it back to the enterprise, to the US, retrain the model, and then push it back again. Then you're collecting more data, and then you're doing inference on the ship. But
Right.
now it's all pushed down within days.
Yeah, and where the latter model that you explained happens, the collecting of the data, the transmitting it somewhere for processing and pushing it back for, for use. I think it's safe to say, in what we're seeing happening in the world today, the battlefield is ever changing. It's never static, right? Whether it's drone warfare or EMP hardened warfare or whatever the case is, it's always changing. And so,
Yeah,
really, I think you're hitting on in a use case that you clearly are testing and validating. You have to bring intelligence to the front lines, and it has to be intelligent enough to be able to react to
absolutely,
the ever changing conditions that security forces are facing.
absolutely, absolutely.
And
And
I think that I
we
think the
built this.
parallel there, my friend, sorry to interrupt, I think the parallel
Yeah,
there for the enterprise is, in the absence of them not having physical AI as perhaps an IT strategy, once they start to really see the value of it, it fundamentally changes their operating processes. And it fundamentally changes maybe even how they build product, they provide services to their clients, and everything else, right? So what you're learning on, in the defense sector, I think has high applicability to the enterprise. Again, sorry for interrupting. I didn't want to cut you off from your thought, but you made a really interesting point, and I saw that parallel.
no, absolutely, right. So what I was going to say was, like, we built this field tactical suite that
Yes,
helps you build and retrain models at the edge,
right.
right? Retaining the models and stuff. For the enterprise, right? Like, as we look at physical AI, we have explored and we have moved ourselves to the left, not just design and train the model. We are also coming into the data side now. We've built an autonomous solution, assisted labeling solution that helps collect all these different sensor modalities, right? Like, from an RGB camera to a EO/IR, electro-optical, infrared, sonar, acoustic data. All of this can be collected, and we're building a tool that can help you label in a semi-autonomous way, right?
Yeah.
We won an Army competition here, labeling images, 2,500 images in less than 18 minutes.
Wow.
Imagine, like, in the white collar job, right? Like, the most excruciating work is the bounding box person, drawing bounding box, and, like, that is the most excruciating, but that has not been fully solved yet.
Yeah.
And we provide the solution as a on-prem deployment, right? Like, you're not sending your data up to the cloud. As you said, like, petabytes of data is collected, and then if you keep sending it to the cloud for somebody to process it, you're losing out. So we provide it on-prem, so you can put it right next to where your data is getting collected, label it right then and there, make it ready, and put it into that cycle.
Yeah. This is where the world is going, my friend. As sort of a parting question, and to slowly wrap us up here, what advice would you offer founders who are building in the deep tech space today? Because there has been so much AI chatter, some for great reason, some just sort of, it's AI, it's the buzzword and people want to say it. But what advice would you give founders in this space?
Two things, right? Like actually, this is an advice for founders as well as for graduating students. I was hanging out with some recent graduates that will be graduating next year, right? So
Yeah.
don't do AI for the sake of AI. Pick a use case, pick an industry. Get yourself expertise in that industry, right? There was an example that a tradesman in the electrical field, he used AI to build an application to help fellow electricians about some specification.
Right.
Very narrow focused, but all of them were spending 60, sometimes 70 hours per project on that problem.
Wow.
He reduced that down to 6 to 8 minutes. Imagine the time saving, right? Like this is like,
yeah.
If you and I are like, let's say I'm not an electrician, but like I would rather be like, doing some exciting stuff rather than filling out paperwork and like, reviewing stuff, right? Like the excitement part of it. So he picked that exciting, the non-exciting part and automated it in such a way that it reduces almost like 1000x time.
Wow.
Right? So that is the advice that I would give to entrepreneurs. Pick a field where you are able to, like everybody has got that monotonous task in there.
Yeah.
Can you automate that? Can you take that away from them and create an automation? And AI is going to be the tool. Let AI be the tool.
Yeah.
Solve the use case rather than trying to AI first, right? Don't pick the hammer up first. Figure out what the nail is, whether it's a screw, it's a bolt, or it's a nail, and then pick whether it's going to be the hammer or the spanner or the screwdriver.
Yeah. And for students, what advice would you give them?
Specialize in a field. Computer science is foundation. It's like knowing math and English. You need to have the computer science and Python language, AI modeling. All of that needs to be foundation. Pick an interesting field for you. If it is plumbing, go into plumbing. If it's electrical, go into electrical. If it is going to be manufacturing, inside of manufacturing, if it is robotics or even like process manufacturing, something, pick a specialization, because that is what is going to save you job. That's where you're going to add value.
Right.
To somebody that's hiring you.
Right. So your sound advice is don't be a generalist, be a specialist.
Yes.
Yeah.
That is good.
And I think you're right, because I know you're right. The implementation of AI today is going to ultimately become so specialized and domain specific, because an OT system in manufacturing operates very differently from an OT system in some other industry. And so those people that do have those skills and insights and can build value from that will stand apart.
Absolutely.
Fun conversations, my friend, as always. I still remember the times where we have pancake breakfasts in Silicon Valley, and so thank you so much. I want to take this opportunity to thank Jags again from Latent AI for spending time with us today, for sharing his perspectives on all matters AI and where the world is going. If there's one takeaway that you've gotten from our conversation today, is that the future AI isn't just in the cloud. It's everywhere, and as Jags would say, it's in the edge continuum for certain. Jags, thank you again for sharing your perspectives and for sharing your journey with us. We really appreciate it. I think we all learned a lot today.
Thanks, Jim. Thanks for having me.
Of course. For our listeners, thanks for if you're thinking about AI and deploying it in the real world. If you're not already familiar with Latent AI, I highly, highly encourage you to check them out. There's a lot that Jags and his team are up to that we didn't have the chance to touch on today, that are really fundamentally changing defense and other ecosystems and industries as well. Don't forget to subscribe to Innovation Unplugged. Leave us a review. Share this episode with your network. And until next time, keep innovating and stay unplugged. Thanks again, Jags.
Thank you.